My dear students, I am Dr. Rajesh Rai. Last class I have given the theory about the Coriolis component of acceleration in the quick return motion mechanism like crank and slotted lever or Whitworth quick return motion mechanism. When the 2 points sliding and rotating, this type of Coriolis component will exist. Now let us see one problem on this. The figure shows a crank and slotted lever type quick return motion mechanism. The crank rotates at a uniform speed of 60 rpm clockwise. The line of the stroke of the ram is perpendicular to OA. Determine the velocity and acceleration of D. You see the diagram. First of all, you draw the diagram. Within all the distance are given. First you mark OA 250 mm. This is a fixed point. From the A, you take AB around 100 mm. Then from the O, you take OC 400 mm. Then C, you mark a length CD around 150 mm. Then keep this line of action of D and O at 450 mm apart. Now, let us see how to draw the velocity diagram. Now, first of all, the 2 points mark O and A, these are the fixed points. Please mark that OA point. Then, angular velocity of the link AB is given. Okay. Now you can see angular velocity of the link AB is equal to omega B 2 pi NB by 60, 2 pi N by 60, 6.28 radian per second. Velocity of the link AB, BB is equal to omega B into AB. Okay, 6.28 into 0.1, this will be equal to 0.628 meter per second. Now draw the space diagram of the given 4-bar mechanism as shown in the figure A with the scale. The velocity equation of the point E can be given by OC is equal to VE is equal to VB plus VEB. Take any convenient point A and draw vector AB is equal to VB 0.628 meter per second perpendicular to link AB with some suitable scale in the same direction of omega B. Take any convenient point A and draw vector AB is equal to VB 0.628 meter per second perpendicular to the link AB with some suitable scale in the same direction of omega B. Since O is a fixed link, point O coincides with A. Now from O, draw a line perpendicular to the link OB, indicating the direction of the slider which intersects the previous perpendicular line at E. From the B, you draw a perpendicular line which will intersect this line. And locate the point C. We will get now OA, B and E. This is located. How to locate the point C? For that purpose, you see the relation OC by OE is equal to OC by OE. OC by OE, whatever the ratio is given in the space diagram, actual values 400 by 320. The same value should be given here, OC by OE. We can calculate OC is equal to 57.5 mm. That one you mark it here. Okay. Now, the velocity equation of the point E on the OC is given by VD is equal to VC plus VDC. From C, draw a line perpendicular to the link CD. From C, draw a line perpendicular to the link CD, indicating the direction of VDC. From O, you draw a horizontal line indicating the direction of the VD, which intersects the previous perpendicular line drawn from C at D. Thus, the velocity diagram completed. Thus the velocity diagram is completed. Now you just measure it. VEB, VE, VC, VD and VDC. Everything you just calculate and it will be completed. All the measurements you take and add it up. Now, how to draw the acceleration diagram? Let us see. Acceleration equation for C is AC is equal to AB plus AEB plus. Now you see the Coriolis component will be comes into existence here. AC is equal to acceleration of B plus acceleration of E with respect to B plus Coriolis component. Coriolis component is always given by 2 into omega EO into VBE. VBE already you know. Okay, omega also you know. You just calculate that value. 2 omega VBE. We can also be calculated. This will be equal to 1.2075 meter per second square. That is what you have calculated. Then each acceleration components are divided into normal component and tangential component. ANE, ANT, ANB, ATB, ANBE, EB, ATEB plus 2 omega into velocity. ANB is equal to VB square by AB. AEN is equal to B square divided by OE. All these values you already from the velocity diagram you got the values of this one. VB square by AB, it comes around 3.94 meter per second square. AEN is equal to V square OE 0.46 square 0.66 meter per second square. 2 omega EO into VBE. Omega you can calculate V by OE, these values can be calculated. Now you see AN B you know, AN E you know, and this component also, acceleration component also we know. Take any convenient point A, first you locate it. Then draw A dash, B dash, which is nothing but A and B 3.94 per meter per second square. Parallel to the link BA with some suitable scale. First step, OA dash into A dash, B dash. This is nothing but A and B 3.94 meter per second square. Next, from X dash means you just take A and E, first you mark it, A and E. This is equal to 0.66 meter per second square. Okay, to the E, parallel to the link AE. Then 0.66 you know, mark X dash. From the X dash draw from B dash you draw Coriolis component of acceleration. This is nothing but 2 WEO VBE. You just take from B dash Coriolis component of acceleration and mark Y dash. Okay, from this Y dash, B dash Y dash is perpendicular to link OC. This is perpendicular to the link OC. Now from X dash you draw a line perpendicular to the A dash X dash indicating the direction of AET. Since O is fixed link point O coincides with the A dash, from draw A dash, X dash, A and E and parallel to the link BO. From Y dash, draw a line parallel to link OC indicating direction of path of the slider which intersect the perpendicular line drawn from X dash at E dash. That E dash is marked. Once you know this E dash is marked, from the X dash you draw a line ATE, you don't know where it ends, and Y dash you draw one more line is nothing but parallel to link OC. It indicates the direction of the path of the slider which intersects the perpendicular line drawn from the X dash at E dash. Once E dash is located, locate the C. Same relation OC by V is equal to O dash E dash by O dash E dash. You see that ratio 400 with 300, 32.5, what you got it, you mark it, 40.025, that lecture. You just mark that O dash C dash. C dash is marked. Once C dash is marked from the point C, now O dash C dash is what? The acceleration equation for a C is AD is equal to AC plus ADC. In this, AD to the power of M, ADD tangential component, AC normal component, and there is no tangential component is not there. ADCT tangential component, ADC normal component. Therefore, ADC normal component is equal to VDC square by DC 0.216. Therefore, from the point C, draw C dash Z dash. C dash Z dash. We can see that C dash Z dash. We can mark here C dash Z dash. It is nothing but A and DC. Mark that it is equal to 0.216 meter per second square parallel to the link DC with some suitable scale. From the Z dash, draw a line perpendicular to C dash Z dash, indicating the direction of ADCT. From O, you draw a horizontal line indicating the path of the D, which intersects the perpendicular line drawn from Z at D dash. Thus the acceleration. From the Z, you draw a perpendicular line which will intersect the point O and draw a horizontal path indicating the path of the D which intersects the perpendicular line drawn from Z at D. Thus the acceleration. Thus the acceleration equation, you got it. Then measure it. Now measure it and calculate all the values. This completes the problem velocity and acceleration equation for a